In this video, you're going to learn about prime factorization. So prime factorization, what we are doing is we take a number and we break it down as far as we can so that it becomes a product of all prime numbers. So for example, if you have the number 12, 12 is not prime, it's composite. I can break 12 down different ways. One way would be taking 4 times 3. Alright, so now 3 is prime because that cannot be broken down any further. It's just 1 times 3 to get 3. The 4, however, is composite, and I can break this down as a product of 2 times 2. So what I have is 2 times 2, and then this 3 here, all multiplied together, would give me 12. Right, so 2 times 2 times 3, those three numbers are all prime. So what we've done is we have taken the prime factorization of 12. So now 12 is broken down as a product, or multiplying, only prime numbers. And there's different ways to do this. So if we took the same number 12, instead of thinking of that as 4 times 3, I could have done 6 times 2. And 6 would break down as a product of 2 times 3. The 2 cannot break down because that is prime, so we just have the 2 still. So I have 2 times 3 times 2. So notice we have the same numbers being multiplied together. The order is different. Here we have the 2 2's first, and then the 3. Here we have 2 times 3 times 2, but it's the same numbers that are multiplied together to get 12. So that is what's called the fundamental theorem of arithmetic, which states that every composite number greater than 1 can be written as a product of prime factors in exactly one way, and the order may vary. So what we've just proven here, what we just illustrated, is what's called the fundamental theorem of arithmetic. We can break down any number, so in this case 12, and there's only one way to break it down as a product of prime numbers. The order may be different, but there's only one set of numbers to get your original number back out when I multiply. So the next couple examples, you are to write the prime factorization. So I will illustrate to you with 3 examples. Here we have the number 20. 20 is not prime, it is composite. I can break 20 down different ways. One way is 4 times 5. The 4 can break down further to be 2 times 2. The 5 cannot break down because that is prime already. So what I have is 20 equaling 2 times 2 times 5. Or I can think of 2 times 2 as 2 squared. So I can write the prime factorization of 20 as 2 squared times 5. So that now the only numbers being multiplied together are prime numbers. Doing the same thing with 36. 36, I can think of that as 6 times 6. So 6 is composite. I can break that down further. 6 would be 2 times 3, and I have that for the other 6 as well. So what I have is 36 equaling 2 times 3 times 2 times 3. And I can simplify a little bit. I have 2 2's, so that would be 2 squared. And then 2 3's would be 3 squared. So 36 equals 2 squared times 3 squared. And now doing the same thing with the number 200. 200 is composite and can be broken down. I can think of 200 as 20 times 10. Well, 20 is still composite. I can break that down as 4 times 5. The 10 also is still composite. That can be broken down as 2 times 5. And then the 5, 2, and 5, those are prime now, so those are good. Those cannot be taken any further. But the 4 I can break down as a product of 2 times 2. So what I have is the 2 times 2 times the 5 times this 2 times this 5, and that would be my prime factorization. I can simplify. I have 3 2's being multiplied together. So that would be 2 to the third power. And then 2 5's multiplied together would be 5 to the second power. So my prime factorization of 200 would be 2 cubed times 5 squared.